All right, next we're going to look at one-to-one functions, a function for which each member of the range, now that member range is kind of like your y values, corresponds to exactly one member of the domain, that's your x value. So one-to-one functions, uh, both should have just one element for each and going backwards. Graphically, let's look at some sets to kind of see what that means. This first set would be one-to-one, meaning each each member of your domain, this is our domain over here, that's our x's, this is our range, that's our y's. Each member of the domain maps to just one thing over here. So that we know means it's a function. The reason we know it's also a one-to-one function is if we reverse the process, everything over here also just maps to one thing over on the other side. Those are one-to-one functions. So the reverse process has to be true too for that to be one-to-one. Over on the right here, this is an example of a function. It is a function. Everything here maps to just one thing over here. We don't have anything going to multiple y values. However, it's not one-to-one. And the reason it's not one-to-one is right in here. When we reverse the process now, 4 maps to both 3 and 2, that's not one-to-one. We only want everything mapping to back to 1 to be one-to-one function. There's a process to see graphically if something is one-to-one, and that's the horizontal line test. Now, this is kind of similar to that vertical line test we had originally. Remember our vertical line test to see if something is a function? If you draw vertical lines and it only hits once, it doesn't hit more than once, that's a function. So we are dealing with a function here. This blue graph is a function. Every vertical line I drew only hit once. To see if it's a one-to-one function, it's going to be one-to-one if and only if no horizontal line intersects the graph more than once. So just like we did before, draw horizontal lines. Now if I draw down here, yeah, only hits once. If I draw a horizontal line up here though, we can see that hits twice. So this is a function. This graph here is a function, but it's not a one-to-one function. So one-to-one functions have to pass both the vertical line test and the horizontal line test to be one-to-one. Let's look at a couple examples here. First off, is this parabola here a function? Go back to our vertical line test. So when we just want to test function, that's vertical line test. So if we go here and we draw vertical lines, is it passing? Absolutely. So we're good there. This is a function. Okay. So now it says if yes, so we're good. Is it a one-to-one function? So now we're checking our horizontal line test. So does it pass that? Well, right away you can see, nope, no, it does not. We're hitting 2 points. A good example of that would be right here if we drew one through 1 here. That point at 1 means that if I do f at 1, the answer comes out to be 1. If I do f at -1 over here, that also maps to 1. So that's okay. That's a function. They're mapping to unique things. But now if I reverse the process, if I did the inverse of these now, and that's what we're going to get to here in a second, inverse of 1. So if we go back the other way, it's going to 2 values. So we don't know exactly what it should map to. Is it going to map to, is the answer going to be -1 or is it going to be +1? That's not a one-to-one function. So is it a one-to-one function? No. Let's look at another example. Is this one a function? Does it pass vertical line test? Yes. Second part, if yes for part 1, is it a one-to-one function? Let's check our horizontal line test. Yeah, here we're looking good. Even right in here, it does really just hit once there. So yes, this is an example of a one-to-one function. Anything that we map to one side should map right back to just one thing on the other side.